Hey guys, Assalamu alaikum. This video is related to salt analysis. You may say the ion detection tests, which we have to perform in all of three papers, how we have to perform in all of three papers. For example, there can be an MCQ related to this analysis. There can be a theory question in which examiner can ask you to identify something, but in ATP paper, there will be a compulsory type of question. We can say that it will be there as a part of your ATP paper. And what will be that question? It will be related to salt analysis. We can say this thing that in case of salt analysis or identification of ions, there will be this sheet available in ATP paper, but in paper of MCQ and in theory paper, you people have to keep this all information in your mind. Okay. What are the tests for? The first test is for carbonate ion. Whenever we are adding any acid mean we can add HCl in this, and as a result, carbon dioxide is going to be produced. Effervescence is there, and carbon dioxide gas is produced. I'm going to share the paper, share the page on which the test for the identification of gases are there as well. I'm going to share that as well. There are three halide ions as a part of your syllabus. One is chloride ion, one is bromide ion, one is iodide ion. When all of these three are there, we are going to add nitric acid. Remember, for the identification of a Cl1 minus ion, we cannot add HCl. Okay, be careful. So be sure about that. Yet you are going to add nitric acid for all of these three. When nitric acid will be added, and then add silver nitrate. As a result, if white precipitates are forming, it will give us an assurance for the presence of chloride ions. Okay, if bromide ions will be present and we are going to add nitric acid along with silver nitrate, cream precipitates will be formed. There can be a difference between the color white and cream. Okay, there are further tests for the identification, detailed tests for the identification of these three halide ions, but those tests we are going to teach you in AS level. At this stage, we are just going to tell you that these are the three ions and they are going to they will be treated with the same type of the substances, and they are going to share you, they are going to show you three different types of the precipitates. Okay, then it is a nitrate, sulfite, and sulfite ions. For nitrate, you are going to add sodium hydroxide followed by aluminum foil, and we are going to warm it carefully. Ammonia gas is going to be produced. Okay, for sulfate, it is nitric acid and then barium nitrate. White precipitates are formed in this case. For sulfite, basically small volume of acidified. Make sure that you are going to differentiate, you should be able to differentiate between sulfate and sulfite. For sulfite, it is a small volume of acidified potassium manganate, and as a result, acidified potassium manganate changes color from purple to colorless. Okay, so make sure that you are going to keep all this information in your mind properly. And then there are the tests for the positively charged ions. These are the tests for the negatively charged ions, and these are the tests for the positively charged ions part of your syllabus. Number one is aluminum ion, ammonium ion, calcium ion, chromium ion, copper ions, Fe2 plus ions, Fe3 plus ions, and zinc ions. Okay, be sure that you are going to keep all these in your mind. Initially, the table which was available through Cambridge has lots of other ions as well, which can create a confusion for a student. But now they have summed it up, and now they are giving you very clear information that you should have an idea about aluminum. Make sure that aluminum ion can get confused you with zinc ion, so please be careful about these. These are aluminum ions with sodium hydroxide and aqueous ammonia. Okay, so these are the two reagents which we are going to add for the detection of these all. Okay, so for aluminum ions, white precipitates soluble in excess, giving colorless solution. What is the meaning of this statement? If aluminum ion will be there and we are going to add sodium hydroxide into it, as a result, white precipitates will be formed. But when we are going to add excess of sodium hydroxide into it, these white precipitates will be dissolved giving a colorless solution. Okay, and then with aqueous ammonia, white precipitates are formed insoluble in excess. Look at zinc ions; it is white precipitates formed soluble in excess, giving colorless solution. So it means that aluminum ion and zinc ions test with aqueous sodium hydroxide is 100% same. Where is the difference? Here is the difference. White precipitates insoluble in excess, whereas white precipitates soluble in excess, giving colorless solution. So the test of zinc ions is similar in this case and similar in this case as well. But aluminum ions are giving this test here and giving a different test with aqueous ammonia. Fe2 plus ions, green precipitates, Fe3 plus ion, red brown precipitates. Okay. But remember that Fe2 plus ions, green precipitates insoluble in excess, and then they are turning brown themselves on staining. Okay, so same here with Fe2 plus ions, they are turning brown on staining. But remember this thing. Okay, I would like to tell you some information about chromium ions as well. In chromium ions, basically a green precipitate soluble in excess. Okay, gray green precipitates insoluble in excess. So please make a difference between chromium ions and Fe2 plus ions as well. Sometimes the students get confused about the green color precipitates of chromium and iron 2 plus iron. So such type of confusion can be created. I'm going to share another sheet with you. Okay, so this is related to the test of gases. Yes, and flame test. Okay, so what is the flame test? We are taking a wire and iron wire, you may say, and we are just soaking that iron wire, or just keeping it in nitric acid, and then, or you may say nitric acid and or HCl. Okay, and acid, you may say. Yeah, that's so that it may have some wet type of stuff on that iron wire, and then trying to make a loop type of thing. And then, for example, if we are keeping it in a lithium salt or sodium salt or potassium salt, copper salt, calcium salt or barium salt, and then we are going to keep it in a flame, such type of colors will be observed. Okay, if red color is observed, it means the salt contains lithium. If yellow color is observed, it means the salt contains sodium. If lilac color is observed, then potassium. I will try to show it to you as well. For example, this is a wire and we have made a circle, or we have made a loop around that, and now we are going to immerse that wire in HCl solution or in nitric acid solution. Some drops of HCl or some drops of HNO3 will be there, will be sticking here. I am trying to draw it here as well. And now you are keeping it, now you are trying to put it in lithium, or now you are trying to put it in sodium, potassium, or you may put it in copper or calcium or barium, and then you are going to keep it in a flame. Then these colors will be observed. Here I'm going to discuss some tests about the gases. If gas is ammonia, turns damp litmus paper blue. If gas is carbon dioxide, turns lime water milky. If it is chlorine, bleaches damp litmus paper. If it is hydrogen, pops in a lighted splinter. Pops in a lighted splinter. If it is oxygen, relights a glowing splinter. Sulfur dioxide turns acidified aqueous potassium manganate from purple to colorless. So, guys, these are the tests for gases. These are the tests for ion detection regarding their flame. And on the previous slide, I have shown you the test for the positively charged ions and negatively charged ions. Positively charged ions are called as cations. Negatively charged ions are called as anions. So you people need to keep these tests in your mind regarding paper of MCQ, regarding paper of theory, and then you have to keep them in your mind regarding your ATP paper as well. In ATP paper, both of these sheets will be there, but you can keep them for the further knowledge regarding remaining two papers. Thank you very much. I'm going to implement this information regarding solving the past paper. I'm going to discuss some of the past papers with you as well. Thank you very much. Take care of yourself. May we all have a good day.